Hello guys, welcome to Team Guru channel, and today we will be seeing about further more topics in fluid mechanics. So the first thing that I want to discuss about in fluid dynamics, fluid mechanics is vapor and gas. So I will be discussing about gas and vapor, then applications of fluid mechanics, then non-slip conditions, then under non-slip conditions I will be discussing about fluids flow separations, right? So moving on to the first one, that is gas and vapor, right? So what is gas and vapor? So gas and vapor are both a synonymous word, right? Same word that does not differ much, as some of the things, some of the parameters which differentiates both the things are the critical temperature, and how far they are from being condensated. So these both characteristics will depend on what it specifies, whether it is a gas or it is a vapor. So taking the case of a gas is far away from critical temperature, and similarly it will not condensate easily. Okay, so it is far away from being condensated, and the critical temperature is not very near to that, it is not very close to that, whereas vapor, it is total opposite to the gas. So where it is very close to the critical temperature, and whereas it gets easily condensated. As I said, so these two things differs in between the gas and vapor, but nothing more than this, which gives a uniqueness of this gas and vapor. So both are synonymous words and both are same. So usually in fluid mechanics there is a two types of studies. Not only in fluid mechanics, every subject if you take, there is a two types of study, where the first one is microscopic study, and macroscopic study. If you see that the microscopic study is nothing but studying in a detailed manner or behavior of each molecule is studied. Whereas macroscopic study, the average behavior of the group of molecules is taken. So for a case, if I study about a molecule's velocity, it's at a microscopic level, the study is known as microscopic study. If I just study the pressure of overall behavior of the gas by connecting a pressure gauge. So it is known as a macroscopic study. So this is for an example. Okay, this is what it is. And application of fluid mechanics. Yeah, fluid mechanics plays a very crucial role in our day-to-day lives. Okay, so starting from water pipeline connections to the air flows in aircraft, and everything deals with fluid mechanics. So for example, in human body, there is a lot of things we can study and relate with fluid mechanics. Say for example, heart, where it pumps the blood through arteries and veins throughout our body. Lungs, where it pumps the air, I mean the airflow through the lungs. So these things are also important, and everything. So by studying this, we have found artificial artificial heart, and for lungs we have respiratory systems available in the hospitals, and dialysis. So those things and all are done with the help of studying the human body. And other than that, pipe systems. So in our house, half of the things deals with the fluid mechanics. So pipe systems, how we make those pipes, we have to measure the pressure, how much potential energy we need to deliver a water from this height from to datum level. So these things and all will influence us the pipe system. And I think I'm just seeing the small amount of applications. There is a lot of applications in our day-to-day life, and I would like to stop it here for the applications. Yeah, coming on to that, next one, non-slip conditions. What is about those that non-slip conditions? Okay, so non-slip condition is a basic thing, basic knowledge to be known before approaching the core part of the fluid mechanics. Okay, so if you see that a fluid is flowing on a rock bed, take a case one, a fluid is moving on a rock bed that contains lots of rocks in irregular shape, and this fluid will have some velocity u, take u, and this fluid encounters the solid body on the way of their path. Okay, so the theory says that when fluid is normal to the solid body, the fluid velocity will decrease and becomes completely zero, right? So the thing is that when, suppose if I take this as a stone and fluid is flowing at a velocity of u, when it reaches the solid surface, the fluid velocity u is equal to 0. Okay, so the fluid velocity u is equal to 0. So this thing is non-slip condition, as this thing will decrease the velocity of upper layer also. Why? How? Because if you see that when a fluid is flowing on a surface, fluid is sticky, I mean it sticks with the solid surface. So the fluid layer sticking with the solid surface will have the same velocity of the plate. Okay, so the layer which is sticky to the surface of the plate will have the same velocity of the plate. Okay, I hope you might have grasped the idea. Okay, similarly there is a cohesive nature, and that is the property of the fluid where each layer, suppose if you take there is some finite layers in this fluid, and this is a layer and this is a B layer. The B layer is sticky to surface, so it attains zero velocity, right? It attains zero velocity, but the fluid has a property that is known as cohesive, that is the interaction between the neighboring molecules will definitely influence the relative layer that is very near to the bottom layer. Okay, so bottom layer will reduce the velocity of the layer above the bottom layer. Okay, so this nature will slowly decreases the velocity of other layers also. So as I want to conclude that the non-slip condition is nothing but the cohesive nature, I mean cohesive property of the fluid will definitely influence the fluid velocity. When the fluid is moving on a plate, will slowly develop a velocity reduction in velocity gradient, where the velocity decreases slowly. This layer will influence this layer, this layer will influence this layer, and this layer will influence this layer. So as the fluid moves on a plate, it will create a boundary layer. So if you see that there is a difference between the velocity, here it is infinite something, if you take it constant or something, velocity of the fluid infinite and constant. Here the fluid at the bottom will have zero boundary here near to the plate, because it is velocity of the plate. And similarly here, if you take some constant n or something, here u is equal to some constant n, right? So this is what the things happen in the fluid when it encounters a solid body. This is the very simple concept and explanation of non-slip condition. And the next thing is flow separation. It is very simple. I would like to give a drawing. Suppose if you take a body like a nose blunt surface, when a fluid encounters the nose blunt surface, like it comes in a u some velocity constant, and when it encounters here, the velocity profile created will be u is equal to 0, and the sticky condition is also happening here where the fluid sticks with the surfaces because of the phenomena non-slip condition, and slowly this water, I mean fluid, will just separate itself from the surface. So the fluid gets off the surface. So this phenomena is known as flow separation. So it is as simple as that. And now, as I told about gas and vapor, they both are synonymous word, which means they are same, not having much differences. And the two things that differs from them is the critical temperature and being condensated. So how far it is being condensated, and macroscopic steady and macroscopic steady. So if you study the behavior of a molecules in a particular system, so that is known as a microscopic study. Macroscopic study is nothing but you are studying the entire system where you ignoring the behaviors of each and individual atoms. And application, there is lots of applications where they have developed artificial respiratory systems, dialysis, and so what we can say, a lot of things like artificial heart and piping systems in our houses, and fluid flow in our bodies, etc. So we learn some things from nature also. And coming on to the thing, non-slip condition. So the non-slip condition, I told that when a fluid encounters a solid body, when it is normal to the solid body, the fluid velocity will attain 0 because of its nature of stickiness, and it sticks to the surfaces. So obviously the velocity of the fluid is equal to the velocity of the plate, so the fluid velocity will attain 0 at the bottom layer, whereas the relative surface between those layers there will be created as a friction, that is known as a viscosity, that is the resistance to flow. So slowly these fluid layers will reduces its velocity. So this is how is non-slip conditions. And finally going to the flow separation, when a fluid encounters a nose blunt surface, the fluid will obviously stick to the surface and slowly it starts to separate its path from the surface. It is that phenomena is known as flow separations. So if you guys found the video useful, please like the video, comment on the video, and do subscribe to Team Guru channel. Thank you guys.